Nvidia introduces Flexicubes, 3D AI. Get ready to dive into the exciting world of 3D graphics and explore the virtual magic behind your favorite movies, video games, AR/VR experiences, and beyond. What makes these digital realms feel so immersive and real? Sure, textures, lighting, and effects play a big role, but there is an unsung hero, the 3D mesh. The quality and precision of these 3D meshes is no trivial matter. It's the difference between smooth, flawless 3D objects that move fluidly versus jagged digital atrocities distractingly far from lifelike. Higher quality meshes drive greater efficiency in asset creation, physics simulation, rendering, and overall performance too. Now, I hope you guys are hooked on the importance of mesh quality, but are also thirsty to uncover the methods and tech behind weaving these digital sculptures. And now, enter Marching Cubes, the prevalent algorithm for crafting 3D meshes. Appreciate its genius, but also limitations begat from its rigid formations. The quest is set to evolve past these constraints to unlock new horizons of 3D potential. And the seeds of this mesh revolution have already been planted by researchers at one of the industry's pioneering 3D graphics powerhouses, Nvidia. Their creation, Flexicubes, is primed to transform 3D mesh generation through the marvelous intersection of geometry, computing, and AI. Marching cubes work by dividing space into a grid of cubes. Each cube is analyzed to find where it intersects with the surface, and triangles are placed to create a mesh approximating that surface. While simple and popular, Marching Cubes has some clear limitations. The resulting meshes have a blocky, angular appearance because triangle vertices are fixed to cube edges. This reduces accuracy and smoothness. The meshes can also be ambiguous with unclear structure, causing issues. Now, you must be wondering, is there a better approach? And the answer is yes. And here enters Flexicubes, Nvidia's new method for high-quality mesh generation through AI optimization. Flexicubes builds on an improved version of Marching Cubes called Dual Marching Cubes. But how is it different? Dual Marching Cubes place triangle vertices at cube centers instead of along the edges. This avoids some of the inconsistencies of standard Marching Cubes. Flexicubes then takes it further by introducing flexible parameters for each cube. These include vertex offsets to tweak vertex positions and edge flips to modify triangle connectivity. Optimizing these parameters during mesh generation allows for precisely fitting the surface based on the underlying data. Additionally, by adapting the mesh locally per cube, Flexicubes can represent details and shapes that basic Marching Cubes cannot. The resulting meshes have smoother surfaces, finer features, and fewer elements while maintaining accuracy. Flexicubes also integrates well with AI and differentiable programming techniques to further refine the mesh. This innovative approach promises to enhance many 3D pipelines relying on mesh generation. The key benefit is the substantial improvement in mesh quality. But what specifically does higher quality provide? For one, it leads to more realistic 3D models in environments to enhance games, VR, and other applications. Smooth, detailed meshes also enable more efficient processing and rendering. Another major advantage is better physics simulations, which rely on mesh quality for robust performance. Let's look at how Flexicubes delivers on these fronts. Firstly, the smooth and precise meshes from Flexicubes represent complex shapes and subtle surface details more accurately. This allows generating 3D models that look amazingly lifelike and natural when animated. The high-fidelity meshes will make virtual objects like clothing, terrain, and furniture, etc. appear realistic. Even meticulously reconstructed 3D scenes can capture finer nuances. Secondly, the optimized meshes with fewer elements improve rendering and workflow efficiency. Fewer mesh data means faster processing and lower computational requirements. Clean mesh topology is also easier to work with for tasks like UV mapping, animation, and simulations. This enables greater productivity. And thirdly, physics simulation, which is integral to interactive 3D applications, is vastly improved using Flexicubes. Unlike basic triangular meshes, It can generate tetrahedral meshes perfectly suited for volumetric simulations, right out of the box. The mesh quality also lends to more stable, precise physics, including factors like inertia and collisions. We've seen how Flexicubes can generate higher quality meshes to benefit many 3D applications. Now, let's look deeper into how this innovative approach actually works. Remember that Flexicubes builds upon an improved marching cubes algorithm called dual marching cubes. The key difference is the addition of adjustable parameters for each cube in the mesh. There are two main parameters that make the cubes flexible. The first is vertex offsets, which are vector values that can shift the vertex positions from their default fixed cube center locations. Second are edge flips, binary values that determine whether an edge should be flipped or not. By optimizing these parameters during mesh generation, the shape and orientation of the triangles can be adapted to fit the underlying surface more accurately. In simple terms, automatic differentiation automatically finds how tweaking the cube parameters will minimize the difference between the mesh and the desired surface shape. The parameters are iteratively adjusted cube by cube until an optimal high-quality mesh is achieved. This local cube-level optimization is key to representing complex geometries and details that would be impossible with conventional marching cubes. The resulting meshes have finer precisions to capture small features as well as smoother surfaces with fewer defects. Another advantage of Flexicubes is the ability to generate tetrahedral meshes. Unlike the triangular faces commonly used in 3D models, tetrahedral meshes are composed of volumetric tetrahedron elements. What are the benefits of tetrahedral meshes? For one, they can much more accurately represent 3D volume and density data. This makes them invaluable for certain types of physics simulations, especially around gases, fluids, and deformable bodies. The simulations can realistically model volumetric effects like inertia and viscosity. Tetrahedral meshes generated by Flexicubes are also tailored for immediate use in physics engines. Alternate mesh generation methods would require additional processing before physics application. This suits the needs of 3D developers focused on interactivity. Beyond these core capabilities, Flexicubes offers some additional advanced features to further improve mesh generation. One is hierarchical mesh adaptation, which creates meshes with varying levels of detail rather than uniform resolution. Areas requiring more detail, like complex subsurfaces, are modeled with smaller elements, while flatter areas use larger elements. This adaptivity reduces unnecessary mesh complexity to optimize efficiency. Another feature is the ability to represent smooth shapes regardless of how rough the input data is. This allows cleanly converting imperfect input, like point clouds, into high-fidelity meshes. Together, these specialized capabilities expand the utility of Flexicubes for complex scenarios. While the technical details may seem dense, what matters is that Flexicubes lifts a major constraint in 3D pipelines: mesh quality, to unlock new creativity. And here arises another question, which is, who can benefit from Flexicubes mesh generation? So let me clarify. It's a boon for developers of 3D engines and simulation tools by providing ideal meshes to showcase their technology's potential. Of course, 3D artists and designers are also empowered to easily create, refine, and amalgamate models. Even novice users can make custom 3D avatars and assets. Flexicubes meshes also lend well to emerging domains, like virtual productions and digital twins. In essence, it paves the path for more immersive, interactive 3D experiences. Nvidia's research and engineering expertise has enabled this huge leap. Let's wrap up by reflecting on the implications of high-quality AI-assisted mesh generation. Until now, we've covered the technical details behind Flexicubes and its advantages. Now, let's zoom out and consider the bigger picture impact of this advancement in AI-enabled 3D mesh generation from Nvidia. Firstly, Flexicubes represents a giant leap ahead of previous state-of-the-art methods. The meshes it creates are remarkably smooth, detailed, and optimized, needing fewer components without compromising accuracy. This effectively future-proofs 3D pipelines to support greater realism and efficiency, especially as compute power grows. Secondly, It underscores Nvidia's leadership in 3D graphics and AI research. Flexicubes showcases their technical prowess and dedication to push boundaries. It builds on their previous work with marching cubes algorithms and differentiable programming for neural networks. The ease of integrating Flexicubes into existing workflows also emphasizes thoughtful design. Importantly, Flexicubes isn't just an academic exercise, but a contribution enabling real-world 3D developers. This was validated by it winning the prestigious Best in Show award at SIGGRAPH 2022, the foremost conference on computer graphics. Recognizing impactful research that seeds broader adoption, this honor cements Flexicubes' role in shaping the future of interactive 3D experiences. Looking ahead, the possibilities are incredibly exciting. As AI-assisted content creation becomes mainstream, Flexicubes will help democratize access by making high-quality 3D affordable and easy to produce. Technologies like virtual and augmented reality will capitalize on detailed dynamic scenes. Even industrial use cases like medical imaging and engineering design tap into the competitive edge of precision meshes. And remarkably, we are still only scratching the surface of what enhanced meshes can unlock across industries and applications. When combined with complementary innovations in AI, robotics, and cloud computing, Nvidia continues to push boundaries and turn imagination into reality with offerings like Flexicubes. The future is meshy,